Hey everyone, today I'm going to do Leak Code question 71, simplify path. And I haven't done this question before, but I have an idea for how I think I'm going to solve it. So let me try testing if that idea is correct. If it's wrong, we'll look at some of the solutions and kind of see what I did wrong there and fill in the gaps. But yeah, I'll try to explain my solution and code it up for you. So I'm thinking, let me write some notes. So let me just quickly walk through what the question is. So you are given an absolute path for a UNIX file system, which always begins with a slash. So always begins with a slash. Your task is to transform this absolute path into a simplified canonical path. So if you don't know what this is, they're going to explain it right here. The rules of the Unix file system are as follows. A single period represents the current directory. To do that, that means current directory. Double period means previous. I don't know how to spell. Current. Multiple slashes should be treated as single slash. So that should be treated as just one slash. And any sequence of periods that do not match the rules above should be treated as a valid directory or file name. So anything that doesn't match that is an actual valid directory. The simplified canonical path should follow these rules. The path must start with a slash. Directories within the path must be separated by exactly one slash. The path must not end with a slash unless it is the root directory. The path must not have any single or double periods used to denote. I think it's easier to go through an example. So for example, let's start with example 1. We need to simplify this into home. You can see the rule, like here, to turn into a simplified canonical path, we kind of need to remove the very last slash, because the path must not end with a slash unless it's the home directory. That's example 1. Example 2. We have this. We could see, well, we need to convert this to just like home foo here, because these two slashes should become one slash like mentioned here. And then finally, this very last element here, we can't have a trailing slash similar to example 1. Now let's go through example 3. So I'm just getting a sense of just reading through the inputs and outputs. So this one, let's just try to guess this without looking at the answer, and that will kind of show how I'm going to build my approach. So we do home, we do user, we do documents, because we said here that any sequence of periods that do not match the rules above should be a valid file directory. Or so like any words is kind of valid file directory here. Let's see. So once we get documents and then we do ... we know that ... means that we need to like go back a directory. So we pretty much have to go back a directory, because that's what single dot means. You stay in the current directory. So if it was dot here, we'll just stay in the current directory. But since it's ... we need to move back one directory. And finally, when pictures come, we get that, and that is the final result. So I'm thinking of using a stack here. That's what I'm mentioning, and just it kind of sounds just using a stack and just building up the URL, and then at the end, like returning that URL. And the reason we need a stack is so if we hit like a ... or a dot, we know we know to pop off of the, like we know to like move back one extra directory, and I'll show exactly how that works in a second. Wow, low acceptance rate. Let's see. Maybe let's just go through one more complicated example. Example 5. And I'll show how I'll be using a stack here. So let's introduce our stack. So we're pretty much gonna just like have one single pointer pointing to all of the different elements of the array. So let's see. So if it's just a backslash, let me throw that into the array. If it's a dot, I'll add it to like the top element of the stack. The top element of the stack. Did we say that path is a valid? Okay, we could kind of assume path is a valid absolute path. So when we convert it, like we don't have to handle all the edge cases, like if they're doing like dot dot at the very start, even though like we're at the very start of the directory. So I'll add the dot here. I'll add the dot here. I'll add the dot here. And then what I'll do is when I get to a backslash, I add all my backslashes. Before I add my backslash, I see if I can if I need to collapse or pop out the last element of the stack. We'll do that. We'll do that if the element is this. We'll do that if the element is this, or the element is this. Like we'll pop either. If it's this, either pop 2. Otherwise, we'll just pop 1. Else, we just throw ourselves on the stack as well. So here, since it's not that, we throw ourselves on the stack and we start a new element. A. So if it's not a forward slash, if it is a forward slash, pretend if it's a forward slash, we get the next one. I'll just join it, or I'll just ignore it if the last element in this, if the last element in the stack is also a forward slash. So to A, and then now we get to this one, and since it's not any of those, we can just add another element here. And then we do dot. So when we add dots, we'll pretty much just treat them like any other character, and just throw them on the back here, or throw them at the top of the very top of the stack, the first element for first stack. Here we get to B, or we get to another forward slash, right? And now we're going to see if we're going to ditch what we're going to do. Since we have 2, we're going to pop 2. And then we're going to throw our element here. Then we're going to throw B here. And then, does that lead? Yeah, okay. I think that's going to lead to the right answer. And yeah, we kind of use a stack, and pretty much if we see dot dot, we pop 2. If we see just regular 1 dot, we pop 1, and we should be good to go. Let's code that up. That's my intuition for it. We're going to use a stack, and we're just going to simply move through the array. So let me just copy over this example 5, because I think that's going to be really useful for me. So what I'm going to do is, we said that we're going to start at the very first element, and we said if, and we're just gonna loop through the whole thing for index, or we're gonna start our stack for index in range, or let's do enumerate. Or for index lm in enumerate. So if you don't know what a enumerate is, I'll quickly print this for you. So what enumerate does is it pretty much just takes like pretend you have an array of like A, B, C. What it does is it returns you an array of tuples where the first element is the index and the second element was like the original element. So yeah, I find this very useful at times when I want to grab the index and have access to both the element and the index of the element for this specific reason. Do I even need that? I'm just comparing. I'm not sure if I even need that for element. Yeah, I don't think I even need that. I just need to look at each element at a time. So yeah, we're gonna start here and we're gonna look at the first element. If the stack is just empty, if the stack dot length is 0, we're just gonna add this first element to the stack. Stack dot append. So now we have our stack. Now we pop the first element in there. If the stack equals 0, if the length, if the length is the stack equals 0. Okay, now if it's not, we're comparing it with the top of the stack. So else, or we'll just do continue, so we don't have to, so we add there. At the end, we're gonna pretty much just take our stack and then join the result. So what we're going to do is we're going to start with the element. If it's a forward slash, we need to if the element is equal to forward slash, we have to do something specific. We have to do that extra logic. Otherwise, if it's not a forward slash, we kind of just add it to the end of, we just add it to the stack. If the stack equals or lm is not equal to that. Oh no, let's just don't over optimize it right now. If the element is not even equal to that, what we're gonna do is we're gonna take the stack. Ooh, this might be an inefficient algorithm because we're adding to the string at the end here. Or like when we create a string here, that's not that efficient because strings are immutable. So if you increase the size of the string under the hood, it's literally creating a new string, and that could lead to O of n time complexity, and it's not that efficient. So I need to figure out a way to just analyze this all by characters. Yeah, I think I could just analyze it all by characters as well. So let's do dot. If it's a dot or if it's anything else than a backslash, we just pop it onto the stack. If the element is not equal to backslash stack dot append element. If the elements or okay, so if the stack equals 0, we just push it to stack. It or the element is not equal to backslash, we just push it to stack dot dot dot. But if it is a backslash, we need to check if any of the elements is we need to check if any of the elements is if the last two elements are so okay, now we do have a front slash. If the so what we're gonna do is okay. Well, I'm thinking what we're gonna do is we're gonna actually check. We're gonna either pop 1 or pop 2 depending on this. So we pop 2 if so we know to pop 2 if the length, if the stack minus 1 equals dot and stack minus 2 equals dot and stack minus 3 equals /. So we're basically just checking if the current stack has the dot dot, because if it does, we're going to have to pop out 6 elements. If probably easier if I do it like this. If stack 3 and stack 2. So if the stack minus 3, so this is like the third element to the left and the second element, the last element. If these elements lead to this exact order, we're going to have to pop out 6 elements. Which stack dot pop? Or do we have to pop out 6 elements? Well, we have to pop out 3 elements at least. And then we also have to pop out, we have to remove like the last directory. So for example, we have documents. Let's just do this simple example right here. Documents. Right. We have our stack. We put D O just do doc DOC. DOC, and then we get this backslash. What do we do with this backslash? We literally just throw it in there. Then what do we do? Dot, 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 dot. And then we see this other backslash. And what we do is we remove 3. So we pop. And then we pretty much we just keep popping. Yeah, we just keep popping up to including we see this element. So we say while because we need to pop out the last element. So you just say dude, this is a pretty good question. There's a lot of tricks to it. Because we also need to handle the case at the end. Handle the case at the very end if we don't hit A. So so we put the stack index at the very while stack dot -1 is not equal to stack.pop and it will do a final stack.pop here. So what this does is it removes the first dot and then it also removes like the next directory after. So pretend we have this. What this extra code does is like when it sees the dot dot and then it kind of closes it, what it's going to do, like we're about to close it, what we're going to do is we're going to stop this, delete that. Then we're going to delete everything up until we see this next one right here. Finally, we're going to delete the last element here. And then after that, I think we could add our one here. Yeah. Then we could finally like stack dot push the last element that we already been looking at. Nice. So that's with 2. With 1, oh, 1 is kind of easy because all we do is we just look at the last 2 elements. And then from there, we just pop those ones out. So it's just popping out 2 elements. And after you add that, you add your final one. What else? Else you kind of drop it. So let's see what the stack looks like at the end. Whoa, what happened here? While the stack okay, let's just go with a simple example. Go with the simple example, and you're seeing me solve this live. Okay, let's debug this. If -1 is not equal to that. What do we have here? Home foo. And we have this extra element. Okay, we can solve that later. Let's try this. Harder and harder examples. Oh shit. I passed in. Oh wow, that solved that. And let's do something a bit harder. Okay, I think all we need to do is handle the last case if. If the length stack greater than 1 and the stack last element is equal to backslash, what we're going to do is we're going to say return pop empty list. Okay, wait. How many? I failed right on my second. Interesting. If there's anything to pop, we'll pop it. Do here again. What's wrong with this? This is kind of how I solve questions. I should probably look at it a bit harder, but let's see. Where did it fail? If oh my gosh, what's going on here? D. Okay. I'm getting close. I solve a bunch of different test cases, but this one is failing. Why? So let's print the stack after every iteration. So I just want to see how the stack like changes over time. Or wait, this one might be easier to just walk through. Let's just walk through this case. So it's complaining that I have D there. If I don't solve this in a few more minutes, I'm gonna have to look at people's solutions and see how close I was, and then so I gotta head to the gym. Let's see, A. So if so I skip that. Then I add B. I kind of build this. And I kind of skip the rest of them. Then I do C. Then I do we do D. Then we only add this. Then we only add this. Then we should pop this. All right. This. We should get this again and pop it. Add back this. Don't add like that. Oh, okay. We didn't catch that case that I was talking about at the end. So if at the end, oh, we got caught with the back case. If we have to do this at the very end again. Probably clean this up, but just trying to show you my intuition. If the stack is greater than 3 and all that, we pop the one and then we pop like the last element out. Oh my gosh. What's going on? 3. Almost there, almost there. We've solved like 10 cases for now, but we're still failing. Where is it failing? If the stack. We'd have to just do balance checks. Holy crap. We've already done 4 submissions and how did this get wrong? Oh my, okay. We need to do we have to do the final check even when we get to the end. Okay, I'm gonna clean the crap out of this code after. Okay, we're almost done. Dude, there's way too many edge cases. I'm just gonna hard code this edge case. I'm just gonna literally hard code this edge case. Please, please. What? That's crazy. Please work, please work. Oh my god. What's going on here? Oh, it's when we get to the back, I thought it was a valid path. Okay. What's happening is when we're getting to the very back, I'm not handling this edge case right here. Look how much spammed solution. So I'm not the edge case. I'm not handling. I literally thought that I forgot that this case even exists. But if we like pop out everything in the stack and we see a dot dot. Okay, let's just do this case. Let's just handle this case right here. Now I'm in a time. I have to rush to the gym. It's all good. This is. You're watching me debug a problem. HOM. Do that. I pop. Why did I only get dot there? Where'd he get this LM from? That's crazy. I think the only case is like if it's empty at the end. Return. Okay, I have to hit the gym now. That took me way more submissions than needed. I don't know how long this video was, but yeah, that's me solving a question from scratch. Let's see what people did. Okay, people are using a stack. Don't follow my algorithm exactly. I need to fix this up, but it ended up passing all the test cases, so yeah, let me run it again. Cool. All right, thanks everyone. I'm gonna hit the gym. See y'all.